All right, let's talk about something every ML practitioner knows all too well. You've spent ages training this perfect machine learning model. You deploy it, it's working like a charm, and then, boom, weeks, maybe months later, its performance just starts to tank. This slow creeping failure, is one of the biggest headaches in production ML, and it has a name: model drift.
And that leads to the big question, right? Why do good models go bad? Now, the first thing you get out of your head is that you built a bad model. You didn't. Your model was probably fantastic for the world it was trained on. The real problem? The world just refuses to stand still.
This really gets to the heart of it. A model is only as good as the data it sees, and well, the world is always changing. Think about it. User behavior shifts, the economy does its thing, new trends pop up out of nowhere. Your model, which is basically a snapshot of the past, gets left behind. It's frozen in time. So the real game isn't just building a great model. It's about understanding how to manage this constant, inevitable change.
So let's dive into what this actually looks like. I like to think of it as a model's silent decay. See, this isn't some dramatic crash where you get a 500 error and alarm bells go off. Oh no, it's much sneakier than that. It's this slow, quiet degradation that happens in the background, totally unnoticed, until, that is, it starts hitting your bottom line.
And here's the thing, this isn't a failure. It's actually a totally normal, expected part of the machine learning lifecycle. I mean, just imagine a model that was trained on shopping data from 2019. How do you think it's going to perform in today's world? It's going to struggle, big time. Why? Because the patterns it learned, the very rules of the game, just aren't valid anymore.
Okay, so to really tackle this problem, we've got to play doctor for a minute. We need to give this illness a proper name and understand its symptoms. You can't treat something if you don't know what it is, right? So let's get a proper diagnosis and define what model drift actually is.
Here it is, plain and simple. Model drift happens when that fundamental relationship between your input data and the thing you're trying to predict changes. That's it. The rules of the game have been completely rewritten, but your poor model, it's still out there playing by the old rulebook.
Now, it gets a little more complex because drift isn't just one single thing. It's more like a family of related problems. First up, you've got data drift. This is when your input data itself changes. Maybe your app suddenly gets popular in a new country, and the user demographics look totally different. Then there's concept drift, which is a bit trickier. This is where the meaning of the data changes. What used to be a strong signal for a customer purchase just isn't anymore. We also have feature drift, where one of your specific inputs just stops being relevant. And finally, the big one, sudden drift. This is caused by some massive event, think a pandemic or market crash, that makes your model basically obsolete overnight.
All right, so we know what we're looking for, but how do we actually catch this drift in the act? This is where we put on our detective hats. We're moving into the monitoring and detection phase. You can think of it like a regular health checkup for your model to make sure everything is still running smoothly.
And luckily, we have a whole toolkit at our disposal to do this. We can get really technical and run statistical tests like the PSI or KS test to compare the new data with the old. Or we can do what most people start with, just constantly monitor key performance metrics like accuracy, F1 score, you name it. And of course, building out drift dashboards to actually see these changes over time is a huge help.
But you know, if there's one metric that has really become the industry standard, especially in high-stakes fields like finance, it's got to be the Population Stability Index, or PSI. It's just a fantastic tool because it boils all that complex change down to a single, easy-to-understand number that tells you how much your data has shifted.
So let's break down how to read a PSI score. It's basically like a traffic light. If you get a PSI value under 0.1, you're into green, all clear. This means there's no significant drift. Your model is stable, it's healthy, nothing to worry about.
Now, if that PSI value creeps up into the 0.1 to 0.25 range, that's your yellow light. It's a heads up. It's signaling some moderate drift. It's not a 5-alarm fire just yet, but it's definitely a clear warning to start digging in and figuring out what's changing before it becomes a serious issue.
And then, if your PSI score goes above 0.25, that's a big red light. Stop. This means significant drift has already happened. The data has changed so much that your model's predictions are probably not reliable anymore. It is absolutely time to take action.
Okay, the red light is flashing, the alarm bells are ringing. What now? What's the treatment plan? Well, there's no magic pill here. There's no one-size-fits-all solution. The right strategy is going to depend entirely on the kind of drift you have and just how bad it is.
But we do have a playbook with several solid strategies.
For those big, sudden drifts, a full retraining on a whole new dataset is usually your best bet. For the slower, more gradual changes, something like incremental learning, where you're constantly updating the model bit by bit, can be way more efficient. If you're dealing with predictable seasonal changes, a simple time-based retraining schedule might be all you need. And when you've got a new model ready to go, you don't just flip the switch. You use a canary deployment to test it on a small slice of your users first, just to be safe.
But let's be honest, all of that manual work can be a pain. The real goal, kind of the holy grail of modern MLOps, is to automate the whole thing. To build a system that's smart enough to handle this on its own. A self-healing pipeline that doesn't need a frantic engineer at 2 a.m. just because a PSI alert fired.
And this is what that beautiful automated world looks like. Step 1. Your system is continuously monitoring the production data. As soon as it detects drift, it triggers an alert and, more importantly, kicks off an automated retraining job on the latest data. Once that's done, it registers the new model version. Then comes the crucial safety step. It tests the new model using that canary deployment method we talked about. And finally, if everything looks good, it rolls out the new model to everyone. If not, it can automatically roll back. This is how you make model drift a manageable, routine event instead of a crisis.
So, let's bring it all home. We've talked about diagnosis and treatment, but what about preventative care? You know what they say, an ounce of prevention is worth a pound of cure. So how do we set up a routine to keep our models healthy for the long haul and avoid these emergencies altogether? Here's your checklist for best practices. First, do everything you can to collect real-time feedback. You need to know how the model is actually doing in the wild. Next, track both technical and business metrics. Accuracy is great, but is it actually helping the business? Third, use a model registry. Version control is not optional. It's essential for knowing what's running and for rolling back if you need to. Always, always, always log your prediction requests. That log data is your goldmine for future retraining. And finally, before you go live with the new model, use shadow testing to see how it would have performed without any risk.
And on the flip side, here are the huge mistakes you need to avoid. The absolute biggest one is just assuming your job is done once the model is deployed. Another classic mistake, having no retraining strategy at all. You're just setting yourself up for failure. Deploying a model without versioning is just asking for chaos. And please, don't ignore seasonality or other time-based trends. Finally, and this is a big one, don't focus only on model accuracy while ignoring the actual business impact. That's how you get what we call silent failure. The model looks fine on paper, but it's costing you money.
So after all this, what's the one thing I really want you to walk away with? It's this thought right here. Models don't just die one day. They slowly decay. They're not static artifacts that you build once and forget about. No, they are living, breathing systems that have to adapt to a constantly changing world. And it's our job, through vigilant monitoring and smart retraining, to keep them alive, to keep them accurate, and most importantly, to keep them valuable.